Hey guys, how do you get things to stick in space? Since the Apollo missions, we've been using Velcro. But it has its limitations. You need two sides for it to stick, and loose fibers can create debris. Can we improve upon it? We're going to talk about exactly that on this episode of Crazy Engineering. Here on Earth, if you want to attach two things together, you've got a lot of different options. But in outer space, none of these things work well. This is Aaron. He's one of our experts in robotics and adhesives. Aaron, how do we solve this problem?
So we've been inspired by geckos. Geckos are nature's most amazing climbers. They go from the floor to the ceiling in 2 seconds, and they can stick to almost anything.
Interesting. So how does a gecko's foot work? Is it super sticky?
Actually, no. Geckos are not sticky to the touch. They have lots of tiny hairs, millions of them, that stick using van der Waals forces.
What are van der Waals forces?
Van der Waals force. The position of the electrons inside an atom or molecule create a polarity, an electric field with a positive and negative pole. This induces a matching polarity in other atoms or molecules close by. The result is a temporary adhesive force between them. We call this the van der Waals force.
Okay, so that's interesting. So how do you actually mimic a gecko's foot?
We make synthetic gecko adhesives. So this is our design. This is 2,000 times the real scale. These hairs are actually much smaller than the hair on your head. And you can turn the stickiness on and off depending on how you load it. So if you just come into contact, this is the not sticky state. You don't have very high real area of contact, not much van der Waals forces, doesn't stick. If you apply a shear load, all of a sudden, high real area of contact, lots of van der Waals forces, you stick. This is how the gecko does it by weighting its feet. This is the real material. You can touch it. It's not sticky at all.
No, it's not sticky. It feels rubbery, but not sticky at all. Okay, so you have to shear it. How do you accomplish that? Do you use a motor? Do you use springs? Can you show us some examples?
Yeah, you can use lots of different mechanisms. So this solar panel, it's a spare from a communication satellite. Here's our Gecko Gripper. We squeeze together, touch the surface. Now we've got it. And to release, you just squeeze and it comes right off. This is a space station panel. This is what the astronauts have inside. You can see there's Velcro on it where they've had to mount stuff in the past. This doesn't need a mating side, so you just stick it to the panel. Now it's on there. You want to move it later, you don't have to reposition your Velcro.
So this technology obviously works great on the surface of Earth. How do you know it works in space?
We have to test it. So we flew aboard NASA's zero-gravity aircraft. It's nicknamed the Vomit Comet. You get about 20 seconds or so of free fall, and we were able to grapple and manipulate a 10-kilogram object and a 100-kilogram object that was actually one of our operators wearing a target.
What kind of applications in space do we need it for?
We can grab satellites to repair them, service them. We can also grab space garbage and try and clear it out of the way. We're interested here in making robots that could crawl around on the outside of, say, the space station, do repair, do inspection.
Aaron, this is all awesome stuff. What else you got going on around here?
Yeah, we got the gecko adhesives for the smooth surfaces, but we actually have other grippers for rocks that use claws, and we have electrostatic grippers, which is like rubbing the balloon on your head. And we put those on miniature robots that can climb up all kinds of surfaces.
Hey, that was all awesome stuff. Hopefully we'll see some of that technology soon up in space. Thanks a lot for watching, and check back soon for some more crazy engineering. Guys, a little help here.